All right, here we are at the end of chapter 4. So let's talk about 4.4, which is all about evaluating. Okay, so we know how to look at scatter plots and talk about the trend and the strength and the shape. We know that we can actually find a measure for the strength with the correlation coefficient. We know how to find the regression line. So now it's just time to evaluate and just talk about some last minute information, like the beware stuff. So let's go ahead and start talking about that. And that will wrap up 4.4. Okay, so here we go. So, some things you got to watch out for that are super important to be careful of is one, again, we've been talking about this for a while. Do not try and fit linear models to nonlinear associations. Don't do it. Okay? No, no, no. Linear, 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 linear is what we want. Okay? Again, correlation is not causation. Even if there is a strong correlation coefficient, like even if it is dead on, the correlation coefficient is -1 or +1, even if it is that strong, it just because there's a correlation does not mean causation. Okay, we've been stressing that for a while now. Now, some other ones to definitely look out for. Look out for outliers. The outliers in scatter plots, we call those influential points. Influential points. And the reason why they have the name influential points in here is because they do influence that regression line quite a bit. Okay, so if you have outliers, they have a big effect. Okay, and because of that big effect that outliers have, make sure that you examine the correlation coefficient and the linear regression model with and without the outlier. Okay, you need to do both. Look at the correlation coefficient and the linear regression with and without the outlier. You need to run it like basically twice. Okay, so be careful with that. Also, be careful with aggregated data. Okay, aggregated data means that each point represents a group of individuals. Okay, you've seen aggregated data before. Whenever we looked at the data, and I can't remember exactly which video it had, I'm pretty sure we had one in 4.2 where it's got aggregated data, but each data point represents a group of individuals. So I know we've seen this, but we have looked at a scatter plot where each dot represented a state's, and it dealt with education. I think one of them dealt with the SAT or the ACT, and it was either a math or English score. So each point represented a state, with the ACT or SAT, math and English being, as your variables. So that's an aggregated data because those values that they used to create those points represented like the mean score of their ACT math, their ACT English, or the SAT math versus the SAT English. That represents a lot of people, a lot of information to create that one name, to create that one number. So look out for aggregated data. Okay, it's better to be able to. Don't get me wrong. You can look at some things, but you just got to be careful because if you look at aggregated data, like if you looked at it individually, sometimes it changes the way that you see things. And I think I might have a picture of this. Nope, I don't. So just so you know, sometimes aggregated data can be a little misleading versus if you actually look at individual ACT math scores versus ACT English scores. Okay. Our book has a great picture comparing the two of aggregated data versus individual data. Check that out in section 4.4. All right. And then this is the last one. Do not perform extrapolation. Okay. So when you guys in section 4.3 looked at the graph and found a predicted data value, like for instance, the one that comes to mind is the one dealing with the mother's height and the daughter's height. When you guys were doing that, you were doing what was called interpolation because you were able to do predictions within the data. Okay. So when you were figuring out the mother's height at 60 inches and then trying to find the daughter's height, that was called interpolation because you were working within our data set to make a prediction. Now, what we're talking about here is do not perform extrapolation. Extrapolation means to make predictions beyond the range of our data. And that could be dangerous because if you try to make a prediction beyond the range of our data might not continue that same trend. Okay. Our data might not continue that same trend beyond the data. So you've got to be very, very careful with that. With performing extrapolation, our advice, do not do it. Only perform interpolation, which means work with inside the data. Okay? Work with what you can see on the data, the scatter plot that you're looking at. All right. Don't go beyond that scatter plot. Okay. So these are things to look out for. Really kind of the three new ones to you are the outlier, the aggregated data, and extrapolation. Everything else that's above this we've talked about. Now on the next page, I kind of gave this away, but you saw that we're going to talk about that R squared. You've seen that R squared pop up on our calculator, and you've seen it pop up on the StatCrunch when we were doing regression. And this R squared, it has a name. It's called the coefficient of determination. Okay. So if you take your, correlation coefficient and you square it, you're getting what we call the coefficient of determination. Okay. What the coefficient of determination is, it is a measure used. We'll just go ahead and show all this. Oh, there was a little bit more, but that's all right. It is a measure used to assess how well a linear model explains and predicts future outcomes. Okay. So this number is to tell us how good our linear model is. All right. And again, as I said, it is the correlation coefficient squared. So once you know R, just take that number and square it, and you're getting the coefficient of determination. Okay. Now, when we deal with this, we report it as a percent. Okay. So this is going to be a decimal answer, and you're going to turn it into a percent. The larger the value, the smaller the variation in the scatter, and the more accurate the predictions will be. Okay. So that's kind of a note here with the correlation coefficient. Not the correlation coefficient, the coefficient of determination. Okay. The larger the value, the higher the percentage, the smaller the variation, the scatter, and the more accurate the predictions tend to be. Okay. So the larger the percentage, another way to think about this is means that our linear model fits the data pretty well. Okay. The smaller the percentage, then our linear model does an okay job and it predicts an okay future. Okay, is generally what this is telling us with the coefficient of determination. All right, so let's check out what's going to happen in our work. So it says right here, if the correlation between height and weight of a large group of people is 0.67, they say find the coefficient of determination as a percent. So, well, we just talked about this. In order to find that coefficient of determination, all you got to do is square that number. And when you square this number, this is what the calculator gives you. So 0.67 squared is equal to 0.4489. And I assume it's going to have you report this as the percent, and probably, I don't know what we'll have it rounded to. So let's round to the nearest percent. So if you multiply this by 100, you get 44.89%, which I'm going to say 45%, rounded to the nearest percent. So there's our coefficient of determination. And then the rest of this question says, explain what it means. It says, assume that the height is the predictor and weight is the response. Okay? And assume the association between height and weight is linear. So based off this, it's telling us that we have that our regression line, it's okay. There's probably a bit more scatter to this than what we like because it's low. It's less than 50%. There's a bit more scatter, and it probably its predictions are, they're okay. They're not the greatest, but they're not the worst predictions. Okay, so that's what this means. And there you go. Coefficient of determination. See, nothing crazy. You got this. And again, when it comes to the explain, it will be multiple choice in the problem. So nothing crazy there. Okay? All right. So right here, I don't think there's much below. No. Let me move. All right. So go ahead, pause the video, give this one a shot. Okay? There's nothing new here. You've done all of this. Okay? So go for it. Okay. So it says the equation of the regression line relating to salary and the first year employed is given by the figure. Okay. So we got the scatter plot. We've got our regression equation. Okay. So they want you to report the slope and explain it, and either interpret the intercept or explain why it's not appropriate. Again, this is stuff that we've done. Okay, so the slope is right here. So this means that as you move up 1 year, okay, as you move up 1 year, you are going to, because it's negative, lose 2.099 thousands of dollars per year in your salary. Okay? So, or not, so basically what it's saying is as it gets closer to our current year, okay? As you go from year to year, on average, you're going to lose 2.099 thousands of dollars per year in your salary. Kind of crazy. Okay. So the intercept for part B is right here. And they've actually told you what the intercept is as a number. Okay. So it says, explain this or interpret this. Again, remember the intercept is all about what happens when your x value is 0. Well, if my x value is 0, that means we're at year 0. And if I'm at year 0, then that means my salary is, in terms of thousands of dollars per year, would be 4,255. Again, in terms of thousands of dollars per year, or the real number would be $4,255,000. So, do you think someone that just started a job in year 0 is really going to be making $4,255,000? I don't think so. So it would be inappropriate for us to really interpret the intercept because again, it don't make sense. All right? So there we go. So a little bit of review of what we've done before. All right, our last problem right here. So it's kind of putting it all together. Okay? So we got this nice little table here. And we're going to go through this, okay? So I'm going to show the calculator first because the very first thing it says make a scatter plot. Okay? Because we've got to know that this is linear. And then from there, it's going to want the correlation coefficient. Okay? And then from there, it's going to want our equation. We're going to interpret the slope and the intercept. And then right here, it's going to give us a new data point. Okay? And this data point is going to throw things off for us. It's going to be an outlier. Because a 30-pound turkey that is free, woo! That's a big bird. And free? Come on now. You don't get no 30-pound turkey for free. All right. So this is going to be that outlier information that I discussed earlier with you. Okay? Let me see. Did we have an aggregated data? This would be aggregated data. Well, depending on where they're getting their dots from. I mean, depending on where they're getting their dots from. If it's one person that they're getting their dot from, yeah, this would be good data. But say each dot represents a country, okay? Say each dot represents a country. It's probably not really a country, or maybe 5 countries, depending on what's going on. So there are 5 countries that report their, what do they say here? Salary. I don't know. Let's say it's their median salary for that year. Okay, so these 5 countries, that would be aggregated data. So each dot represents the year and the median salary for their country in that year. So that would be aggregated data because that median salary is made up of a ton of people. But without further information, I can't really say that on this, so that's kind of bad form on my part, but just kind of give you an example of that. And so as we go each year, we've got these countries that report their median. That would be aggregated data. But it looks like probably that this is all individual data where it's one person that started in 85 and this was their salary. One person that started in 90 and that was their salary. So this is actually good information, okay? Because it's not really aggregated, as I was saying, but I wanted to kind of talk you through kind of an example of that. All right, so let's get back to this guy. So we're going to take this information, we're going to put it into our calculator. So we're going to go to Stat, Edit, and our data pieces are 12.3, 18.5, 20.1. 12.3, 18.5, 20.1. Okay, then we have 16.7, 15.6, 10.2. 16.7, 15.6, 10.2. Let me make sure of that. 16.7, 15.6, 10.2. Okay, perfect. And then price, $17.10, $23.87. So we're going to scroll over. $17.10. And I already forgot the other one. $23.87. $23.87. And then we've got 2673, 1987. 2673, 1987. And then last but not least, we've got 2324 and 908. 2324, 908. 2324, 908. Okay. So now we can go, and the first thing says, find the scatter plot. So hit second, y equals, turn on the scatter plot. So hit enter, and then now go to zoom and scroll down to number 9. Okay, or you could just actually hit the button 9. And there's our scatter plot. So definitely seeing a positive association here. Okay, so our line would definitely have a positive slope. Okay, so let's jump back in here. So we made the scatter plot with weight on the x-axis. Yeah, so all that's good. And let's go and let's put this information into StatCrunch. Okay, so this is the weight. This is the so, and we'll get that scatter plot drawn up at the same time. So 12.3, 18.5, 20.1. 12.3, 18.5, and 20.1. Okay. Again, I like working with StatCrunch a lot better because you're going to get all of your information right up front, where in the calculator, we got to go and we got to get onto another screen. So 16.7, 15.6, 10.2. 16.7, 15.6, and 10.2. 1710, 2387. 1710, 2387, right? 2673, 1987. 2673, 1980. Was it 1987? Yeah, 1987. And then 2324, 908. Okay. So 23, 24, and 908. And then we go to stat and we run regression. And again, we're going to choose the weight as the x and the cost as the y and compute. Lots of information, but again, there's our scatter plot. And I love it. It looks nice. It's actually giving us our line and all that good stuff. All right. So going back here, we've got that. So it says find the numerical value for the correlation between weight and price, so the correlation coefficient, and then explain what the sign of the correlation shows. Okay, easy peasy. So if we're in here, remember when you do this to find that correlation coefficient, make sure that you hit second 0 and make sure that you've turned diagnostic on. Okay? So that's one thing. So we want this diagnostic on. So scroll up to it, hit enter, enter. So it's on. And now when you go to stat, calculate, go down to number 8 because this is the one that we want. Hit enter, and it's all good. Either scroll down to calculate and hit enter, or hit enter 5 times. So here is our R. Hey, look, there's that coefficient of determination. So here's our R. So it's 0.933. Okay. And if you're in StatCrunch, there is the R, and the R squared is right below it. So their R actually was a little bit different. Uh-oh. Did I put something in wrong? Let's look at their, yeah. Okay, so I got to check my data real quick. Make sure that I put it in correct because I have 2 different pieces of information here. 12.3, 18.5, 20, 16 points. I did. This should be 15.6. The other data real quick. So this is always good to check your data over. Because if something in there is wrong, you got to fix it. All right, let's go back to this. Let us delete this, and let's rerun our regression because they should have matched 100%. Weight, cost, compute. There we go. That looks better. Let's look at, sorry, I'm going to make sure that this, oh, gosh darn it. All right. So 1.7519. Yeah, and it just rounded right there. So that's looking good. And then negative 4.88. Yep. Yeah. We're matched now. Okay, good. So here is that 0.933. And then again on StatCrunch, it matches it 0.933. All right, so we go back. So we know what this is now. 0.933. And what does the sign of the correlation mean? So because this is positive, that means that we have a positive association. Okay? Which tells us that our slope should be positive. Okay? So lots of good things there. We have a positive trend. We are increasing from left to right. All those mean the same thing. All right. So now it says report the equation. Okay. So if you're on the calculator, this guy is your intercept. This is the, excuse me, the slope. Which is great. You can write all that out. But if you go to StatCrunch, look right there. It gives you the equation. All you got to do is just copy it over. And I'm going to round to the nearest thousandth again, 3 decimal places. So we're going to have predicted cost. And I'm actually going to move this down here because it's going to be a little bit longer. And that C looks like an E, so let's fix that. Predicted, oh, that's horrible. Let's just rewrite this. Predicted cost equals, and negative 4.488 plus 1.572. 1.572 weight. There's our equation. Okay. So part D says report the slope and the intercept. So the slope is right here. That's the M. The intercept is right here. Okay, and explain what they show. So again, the slope right here means that as I increase by 1 pound, the average price increases by basically $1.57. So as I increase by 1 pound, or as I weigh 1 pound more, my price is going to increase by $1.57. So there's the slope, the average price, I should say. The intercept means that if I have a turkey that weighs 0 pounds, then someone is going to give me a $4.49. That's what it means to be kind of like this right here is negative. In terms of money for this one, it means that someone's going to give you $4.49. So if I go up in a store and I say, hey, I've got this turkey that weighs nothing, in other words, I don't have a turkey, you're going to give me $4.49. Yeah, they're going to look at me like I'm stupid, and then they're going to call security, and I'm going to go to the nut house because they're going to say, because I'm telling them that the store owes me $4.49 for nothing. So the intercept is not appropriate, okay, because it doesn't make any sense. All right, last but not least, we are going to add a new data point, and we're going to do a new regression. So this is where the calculator kind of falls a little bit on its head, because now I'm going to lose all this beautiful information, and I'm going to lose my graph that it created already. Where in StatCrunch, I can keep both of them. So I can add in the weight of the 30-pound turkey and the price being 0 and create a whole new graph, but still keep what I already know. So that's why I like StatCrunch. So we're going to keep the weight, and we're going to put the cost, and we're going to compute. So notice my new information now. Okay? Notice my correlation coefficient. If you look at this, oh, look what happened now. My outlier changed my line completely because it's all the way over here. Okay? So interesting. So let's see what it wants us to do with this. Okay, so we add that, give the new R and the new regression. Okay, so our new R is 0.375, negative 0.375. So negative 0.375. Our new equation, so predicted cost equals, sorry, wrong screen. So 26.868, wrong screen, 26.868, and this time it is a minus. And it tells us that the slope is 0.553, 0.553 weight. Now it says explain what the negative correlation implies. Okay, so the negative correlation for us implies that this now has a negative trend, but if you look at this, it's really low. It's not close to -1 at all. It's closer to 0. So that means in this piece, it means that it's a very weak sauce association here. Okay? It's very, very weak. Okay? So what happened is that outlier completely changed everything for us. So if you look at this, that outlier, I mean, this is why you want to look at outliers with and without, because that outlier completely changes our regression line. All the data really points to a positive trend, and then this guy comes along, and now it's a negative trend. Okay? So with an outlier, without an outlier, it's important to look at both. All right? So from here, that ends section 4.4. Your questions now, 46 to 53. So all of chapter 4 is ready for you to kick butt on and get it done. Thanks for stopping by, and I'll see you next time.